Alright, so welcome back to another quick math tutorial. Today we're going to be taking a look at some vector problems, and we're going to be approaching our vector problems with our problem solving techniques. And as I said, if you learn these problem solving techniques, then you can pretty much approach any math problem with confidence, because once you build the competence, then confidence will naturally follow. It's kind of like riding on the back of someone's motorcycle, right? Would you prefer the person to be confident driving, or would you prefer them to be competent? You'll much prefer them to be competent, wouldn't you? And so if we go through these problem solving techniques and we apply them to any maths problem, then you are guaranteed to feel confident really with any type of problem that you're approaching. Alright, so saying that, let's go through a few of these points here on problem solving. So the first point would be to read the question carefully, very carefully. If you do not read the question carefully, you could miss out key pieces of information, and you may not know exactly what it is that you're trying to find. The second point would be to ask yourself, what type of problem is this? What special information or formulas do I need to know to solve this problem? Think about what formulas and mathematical techniques you need to know in order to solve the problem. For example, if the question is about circles, you will need to know some circle theorem. Some and most all of the questions you will need to draw on. Some and most of all the questions you will need to draw on your knowledge from various places, for example, ratios and vectors, in order to solve the problem. What extra information can I obtain from that already given? See what extra information you can gather from the information already provided. For example, the question might say, in a class of 30 boys and girls, 35% of the boys did so and so. You can infer that the other 65% of the students are girls. In this way, you are filling in data that could be, and in most cases is, vital to you solving the problem. If you're engaged in a problem which involves any kind of geometry, like the questions that we're actually going to be engaged in today, we're going to be looking at some vector geometry, then draw extra lines. If there is an unknown which you are trying to find, label it as X, Y, or Z. Okay? Now, I'm not going through these points word for word. I'm actually just paraphrasing, but you get the drift. Just follow along. Forwards, backwards thinking, which is really just another name for induction and deduction. It's just that I thought the term forwards, backwards thinking is a lot easier to remember, and it kind of makes a lot more sense. Alright, so work backwards from the problem. For example, the question asks me, prove that XYZ is a straight line. In vector geometry, I know that XYZ is a straight line if XY is a scalar multiple of YZ or XZ. So now I have reduced the question to, I must show that XY is a scalar multiple of YZ or XZ. I can continue in this line of reasoning, reducing the question further. I can say, in order to do this, I must first work out XY in vector form and then find XZ. In this manner, I am going backwards from my question, and I'm actually reducing my question into smaller chunks. Alright, so going forwards means that with any information which I obtain from my problem, implied or given, I try to obtain more information from the information I have already obtained. In doing this forwards backwards motion, I meet somewhere in the middle and I find my answer. This is a very important step, by the way. You're basically going to be doing this step in all kinds of problems that you approach. Now this step is for, okay, so we have our next one. Write down your thoughts as you go along. So write down your thoughts as you go along. Helps you to keep on writing down your thoughts as you go along, helps you to keep on top of your calculations. The problems might require many steps to solve, and you may find yourself forgetting what it was you were going to find at each step. Only write down your steps once you have decided that they are the right steps to follow. You don't want to set in stone what might be incorrect. Again, as you're writing down your steps as you go along, if you haven't properly really thought out your solution, and you write down a wrong plan or some wrong steps, then you might find yourself going along with the steps even if they don't make sense. And it's kind of like you set them in stone, right? That's where we have the saying set in stone. And so your brain is telling you this is the way to do it because I've written it down. And you don't want that. So you want to make sure you have a clear plan to follow before you start writing things down. Now this one's very important for if you get very stuck. And it's once you eliminate the impossible, whatever remains, no matter how improbable, must be the truth. So trust your logic and reasoning. If the truth is limited to either A or B or C, and by the way, I got this from Sherlock Holmes. So if the truth is limited to either A or B or C, and you investigate A and B and find they are both impossible, then C must be true. There might be a certain answer or way of solving your problem that seems incorrect. However, if you find that there is no other way of solving the problem, then the method that you have might be in fact the correct one. There is just something that you might be missing in order to make it work. And finally, we have always check your answer and your calculations as you go along. Always check the numbers that you plug into your calculations. Your calculations could be right, but you may have written down a number wrong, and as a result, your whole calculation could be incorrect. Alright, so knowing that, let's get cracking with our problem. So, like some red ink there. So OABC is a trapezium. OABC, that's a trapezium. OA equals A, this is OA, and of course when we're saying OA you see a little arrow on top of there, so it's saying from O to A, so you're going in the direction of O to A, and that equals A. AB here going in the direction from A to B equals B, and OC here, O to C equals 3B. Here we have our little arrows as well showing us the direction. D is the point on OB, here we have D. And here we have another a line OB here, OB, and D is a point on OB, such that OD full colon DB equals 2 full colon 3. E is the point on BC, this is our point E, such that BE full colon EC equals 1 full colon 4. Work out the vector DE in terms of A and B. Give your answer in its simplest form. So we want to find the vector DE, which is this part here, this vector here, DE. So just referring back to my notes, I've read the question carefully. Ask yourself, what type of problem is this? What information do I need to know? Well, looks like it's a vector problem. And I also have some ratios thrown in there for good measure as well. So I need to have a fairly good understanding of ratios. What extra information can I obtain from that already given? Well, let's see. And also, if we read back to that, it says draw any extra lines if we're engaged in a geometry problem, and this is a vector geometry problem. So I have drawn some lines in here. Also, it says here that OD full colon DB equals 2 full colon 3. So this is OD here, OD, and we're saying that it's 2 to 3. DB is 3. So in total, we can say that this line OB is actually made up of 5 parts, and that's from OD is 2 parts of the line OB, and DB is 3 parts of the line OB. Alright, so we're filling in a bit of extra information. We're writing on our problem just to get a clearer picture of what's going on. So let's see. So also for E is a point on BC. Here we have BC and we have a point E here on BC, such that BE full colon EC equals 1 full colon 4. So this BE here and EC is one part, this BE is one part of the line, and this EC is 4 parts. So in total, again, we actually have 5 parts here. So BC, it has a total of 5 parts to it, okay? So work out the vector DE in terms of A and B. So if we go back to our problem solving techniques here, we have forwards, backwards thinking. So I'm going to attempt to work backwards from my problem. So if I want to find DE, where's DE? DE's here. We know that in vector geometry and any kind of vector work, we never want to go directly from D to E. We want to go indirectly, a bit like a crab, because a crab never goes directly towards its target, it always goes around, right? And we have to go around in a triangle fashion, so we have to find the nearest triangle that we can travel around to get from D to E. So there's no other triangles apart from this triangle here. Notice this is not a triangle, this is another trapezium. So we want to go in a triangle manner here. So we can go, to get from D to E, we can go from D to B and then from B to E. Okay? So I can travel from D to B and then from B to E. So in order for me to find DE, I must go from D to B to B to E. Okay? So let's write this down as we go along. In order for me to find DE, I must find DB and BE. Okay, so now I've reduced my question, I've worked backwards from my question, and I've reduced it now. So now my goal is to not just to find DE, but I have to find DB and BE in order for me to find DE. So now I've reduced my question down further to I need to find DB and BE. Okay, so, and that's the reason why that is because DE equals DB plus BE. Okay? Alright, so I need to find DB. So how do I find DB now? Well, I have to realize that in fact that DB is actually part of the line OB. Okay, in fact, in general, in particular, it's actually 3 parts of the line OB, isn't it? The same way OD is 2 parts of the line OB, DB is 3 parts of the line OB. So I need to find OB first of all, and then once I find OB, then I can kind of split DB off from the line OB, right? So what's OB? So remember, to find any vector in vector geometry, we have to use our triangular law, which means we can't go directly from O to B. We have to go around any closest triangle. Notice that this triangle here, this OAB, is the closest triangle, the only triangle that I can really travel around to get from O to B. Alright, so I need to find OB. So OB, notice that OB equals OA plus AB. OA plus AB. Okay, so OB equals OB equals OA, which is A, plus AB, which is B. Okay, so now I've found OB. Alright, so remember, the reason why I wanted to find OB is because I wanted to find DB, and I realized that DB is a part of the line OB. So notice that this whole line OB equals 5 parts. It has 2 parts to it plus 3 parts, so it's 5 parts. Now DB is 3/5 of the 5 parts, okay? Or we should say it's 3/5 of the line OB, okay? It's 3 parts out of the whole 5 parts, which we can say 3/5 of OB. So DB, remember, we're actually trying to find DB and BE to find DE, okay? DB equals 3/5, because it's 3 parts of the whole line, and the whole line is 5 parts in total, so 3/5 of OB, which means that DB equals 3/5 of A plus B, which means that DB equals 3/5A plus 3/5B. Alright? Okay, so we found what DB is. So let's just go around that. I have found DB. Okay, so next, I found DB, that's crossed off. So now I want to find what BE is. Okay, so notice here again that BE is part of the line BC. Okay, so in order for me to find BE, I should find the whole line BC, and then I can split a part off of it, right? So I'll put green. Alright, green. Alright, so I want to find BC, and remember, as vectors, for vectors, we can never go straight ahead. We have to use the triangle law. We have to, if I want to get to B to C, I have to be like a crab. I have to go around to get from B to C. In fact, and by going around, I actually find out my component vectors. Okay, so I have to go from B to O, and then from O to C. So BC equals BO plus OC. I remember, why am I finding BC? I'm finding BC because I realized that BE is a part of the line BC. So if I find BC, then I can work out what part of the line it is. So BO, we want to find BO now. Now notice that BO is the opposite of OB, right? And we found what OB is here. OB equals A plus B. So BO, since it's the opposite direction of OB, it must be the negative of OB. So BO equals negative OB. So BO equals minus A plus B, which gives us minus A minus B. Alright, so BO equals minus A plus B, or minus A minus B, sorry. Minus A minus B. Alright, so I found what BO is. So I found what BO is. Now I want to find what BC is. Remember, I'm trying to find, sorry, OC is, remember, I'm trying to find BC. So in order for me to find BC, I need to find BO and then OC. So I found BO, so now I need to find OC. OC is already given, it's 3B. Okay, so OC equals 3B. So BC equals BO, which is minus A minus B, plus OC, which is 3B. Alright, so BC equals minus A minus B plus 3B, which is minus A plus 2B. Alright, so I have found what BC is. And why did I want to find what BC is? Remember, BE is part of the line BC. In fact, the line BC has 1 part plus 4 parts equals 5 parts. So the line BC is 5 parts in total. And BE is 1/5 of the line BC. So it's 1 part. BE is 1 part out of the entire 5 parts, just as EC is 4 parts out of the entire 5 parts. So if we say 1 part out of the entire 5 parts, we might as well say 1/5. So BE equals 1/5 of BC. Okay, and so we know what BC equals. BC equals minus A plus 2B. So BE equals 1/5 of minus A plus 2B. And so BE equals minus 1/5 A plus 2/5 of B. Okay? So I found BE. So now I found DB and I found BE. Remember, I wanted to find what DE is. And in order to find what DE is, I have to go from D to B and then from B to E. Okay? And where is it? It's up here, right up here. Remember, this is the formula that the initial formula that we wanted. So I found DB, that's there, and I found BE. So now I just add them together. BE, no, sorry, DE, we're trying to find DE, equals DB, which is here, 3/5. In fact, I'll just write it again up here. BE. Alright, so D equals DB. And we found DB. DB is 3/5 A plus 3/5 B. So DE equals 3/5 A plus 3/5 B plus, do that in brackets, plus BE, which is minus 1/5 A plus 2/5 B. Okay, and that gives us, we have 3/5 plus minus 1/5, so we're left with 2/5 of A, 2/5A. Then we have here 3B, 3/5 of B plus 2/5 of B, which just gives us B plus B. And there's our answer. DE equals 2/5 A plus B. And notice we've expressed it in terms of A and B. Okay? So that's our answer. So let's now move on to our next vector question. So this is my next vector question here. Oh, and by the way, we have, after this one, we're going to be doing this one, and then this one. We'll save this one till last. This is the juiciest question, so we'll save that one till last. Alright, so we're on to our next question. Alright, so we have DEF is a triangle. DEF. P is the midpoint of FD. Where's P? P's here. P is the midpoint of FD. And by the way, what does a midpoint mean? It means it's halfway between the points F and D, which means it splits this line exactly in half, right? So we're just let's refer back to our problem solving notes again. So we're reading the question carefully. We're going to ask ourselves, what type of problem is this? So we haven't even finished reading the question carefully, so let's continue. P is the midpoint of FD. Q is the midpoint of DE. So where's Q? Q is here. And that's the midpoint of the line DE. FD equals A. FD equals A. So this whole point here is A. So we're reading our question carefully and we're just filling in information. FE equals B. Here we have FE. In fact, I'm going to draw my little line here as well on each of them, just so we know which direction we're going in. F to D and F to E. And that equals B. Okay, use a vector method to prove that PQ is parallel to FE. Alright, so notice here that we're not actually given the line PQ. Here's PQ, we're not given a line, so what do? We refer back to our notes. We'll refer back to our notes. It says, what extra information can I obtain from that already given? And it says, if you're engaged in a problem which involves any kind of geometry, draw extra lines. So that's what we're going to do here. We're going to draw our extra line here just to fill in and give ourselves a complete picture of what's going on. That's my extra line there. Okay, and I'm going to put an arrow there to show that it says P, going from P to Q. So we want to use a vector method to prove that PQ is parallel to FE. Alright, so if we're using our problem solving here, let's go with some backwards thinking. Alright, we're going to be thinking backwards from our problem. Okay, so use a vector method to prove that PQ is parallel to FE. Alright, so if PQ is parallel to FE, what does it mean that PQ is parallel to FE? What kind of special information do I need to know? Alright, what kind of special information do I need to know in order to solve this problem? Well, I need to know what makes two vectors parallel. What makes two vectors parallel? What makes two vectors parallel? Well, two vectors are parallel if they are both scalar multiples of each other. Remember, if I was to just draw a few vectors here, let's say that vector equals A, then if these two vectors are parallel, then this vector must be, for example, let's say 2A, right? Or we could have a smaller vector here, and that could be half A. Half A. This vector is also parallel. It could just be going in the opposite direction, but it's still parallel, and that could be minus A. Okay. And a vector, this kind of vector here, that wouldn't be parallel to any of the vectors. Okay. Alright, so in order to show that PQ is parallel to FE, I need to show that they are scalar multiples of each other. Okay, so now I've reduced my question to, I must show that PQ is a scalar multiple of FE. Okay? So in order for me to show that PQ is a scalar multiple of FE, I actually have to find PQ. I already have FE, that's B. So now I've reduced it even further to in order to do that, I must find PQ. Alright, so now begins the task of finding PQ. So I have to go from P to Q. And remember, I have to go in the form of a triangle, okay? I have to get from P to Q via a triangle. So how many triangles? There's a triangle here. I can either go from P to D and then from D to Q. Notice there's another triangle here though. I can go from P to E and then from E to Q. Now I would show you both methods. I would go from show two triangles, but we don't want to get too cumbersome here, so let's just stick with one. I'm going to choose this top triangle here to get from P to Q. So PQ equals PD plus DQ. Okay, so we know what PD is. Notice that this point P divides FD into half, and this whole line FD equals A, so this part must be half A and this part must be half A. Okay, so PD equals half A. PD equals half A. Okay, so now I need to find DQ. Alright, so there's not really any way of me finding DQ apart from, because nothing's given here. So in order for me to find, the same way for me to have found PD, I had to have known this whole length FD. Okay, and the whole length FD was A, so I reasoned that P is midpoint between FD, so this part here must be half A. However, I don't know what DE is, so I need to find DE. Notice that DE, in order for me to find DE, so let's just write down must find DE. So remember, for me to find DE, or the component vectors of DE, I can't just go from D to E. I have to kind of collect my vectors as I go around, right? So notice that this DE is part of the big triangle DEF, or we can just say DFE. So I can go from D to F and then from F to E to find DE. Okay? So I'm going to write that down. So DE by the way, let me just fill in this part. Must find DE to find DQ. Okay? So DE equals DF plus FE. Alright? So I know what FD is. FD is the vector going from F to D, and that's A. So DF is the opposite of FD, so it's negative FD. Okay? And so DF equals negative A, because FD equals A. DF equals A, negative A. Alright, so I have DF, DF equals minus A. So now I need to find FE. well, I have FE already, it's B. So FE equals B. FE equals B. Okay, and so where are we? So we want to find DE, and DE equals DF plus FE we have here. So we just add them together. DE equals DF, which is minus A, plus FE, which is B. Alright, so now I found DE. And why did I want to find DE? Let's see if we can remind ourselves. Must find DE to find DQ. Remember, I wanted to find this DQ here. Okay. So, and remember, why did I want to find DQ? Because I wanted to find what PQ was. Okay, so I needed to find PD and then DQ. So I found DE, and notice that Q is the midpoint of DE, so it splits DE into half. So DQ must be half of DE. And so DQ equals half of DE, which is half minus A plus B. And so DQ equals minus half A plus half B. Half B. So I found DQ there. Alright. See if I can write. No, we won't write it there. There's not enough space. So I found DQ. Alright. Alright, so now I found DQ. So I have PD and I have DQ. And PQ equals PD, which is this part here, plus DQ. Alright? So where is our PD? Where do we write PD? PD is there. I should have highlighted that there. PD. Okay, so I have PD here and I have DQ. So now I can just add them together here. Notice we have our formula here. So we just add them together. So PQ equals PD, which is half A, plus DQ, which is minus half A plus half B. And if I was to simplify that further, I have half A plus minus half A, so that just cancels out completely, and I'm left with half B. So PQ equals half B. Half B. So I found PQ. Now why did I want to find PQ? Let's go back up here. I must show that PQ is a scalar multiple of FE. In order to do that, I must find PQ. So I found PQ. So now I can show that PQ is a scalar multiple of FE. Well, what does PQ equal? It equals half B. And FE equals B. So I've shown it. PQ equals half B. And we know that B equals FE, so PQ equals half FE. So I've shown it. PQ is a scalar multiple of half FE. Here's my scalar multiple here. And that's a scalar multiple of FE. Okay? Alright, so let's move on to our next vector question. Alright, so I have my next question here. And again, let's always refer back to our problem solving notes. So first we want to read the question carefully. Alright? So OABC is a parallelogram. OABC. Alright, that's our little parallelogram there. And OA equals A. This is our line here, OA, and that equals A. OC equals C. X is the midpoint of the line AC. Okay, what line AC? I can't see any line AC. So what I'm going to do is I'm just going to fill in here a line. I'm going to go as straight as possible. So that's my line AC. I'll draw a little arrow there to show I'm going from A to C. And X is the midpoint of that line. So X is about there. X marks the spot. And we have OCD is a straight line, so that OC full colon CD equals K full colon C. So again, where's OCD? We have OC, but we don't have D. So we can, if we're saying that OCD is a straight line, then it must continue on from there. It's not really straight, but you get the picture. So we could say, we could label this point D. Okay? Label that point D. So we have our line, our straight line OCD. So OCD is a straight line such that OC full colon CD equals K full colon 1. So this point OC would be K, and this point CD would be 1. Alright, so what else do we have? We have, given that XD, where's XD? Again, we don't have XD here. XD would be this point to this point. So what we can do is we can just fill in another line. I'll do this in a different color. I'll fill in another line here from X to D. Go. That's our straight line. Our kind of straight line there. Alright, so I'm going to put an arrow there going from X to D. Alright, and given that XD equals 3C minus half A, so I'm going to write just above here 3C minus half A. Okay, find the value of K. Alright, so let's refer back to our problem solving notes. So we read the question carefully. What type of problem is this? What special information or formulas do I need to know? Alright, so the special formulas that I need to know, or special information, is I know it's a vector question, that's for sure. And I also have some ratios, again, thrown in there for some good measure. Alright, so I need to have a fairly good understanding of ratios. Alright, so let's refer back. What extra information can I obtain from that already given? Well, I've drawn in some extra lines there. And so forwards, backwards thinking. So for this question, because it's a little bit more difficult, it's a bit hard to try to work backwards, because I don't really know what I'm working backwards from, you know? I know I need to find K, but, you know, how do I work backwards from that? So the best thing to do here is to be working forwards. I need to be going forwards. And what that means is that I just need to start filling in more information just to give myself a better picture, a more fuller picture of what's going on. Alright, so notice here that I have the vector components for this line. I don't have any vector components for this line. Neither do I have any vector components for this line. So I can't really find any vector components for this line offhand. I might need to fill in some more information. So, but I can possibly find the vector component for this line, because this line here is part of the line AC. Notice it's part of the line AC. Okay, and there's a triangle here linking me to the line AC, and both of the vectors components here are given, A and C. So in order for me to find AC, I need to go around this triangle here. So I need to go from A to O and then from O to C. So I'm working forwards here. I'm just filling out more information just to give myself a better picture, a fuller picture of what's going on. So AC, let's write it up here. AC equals AO plus OC. Okay, so AC equals AO. Notice that AO is the negative of OA. We're going in the opposite direction of the arrow, so that's going to be negative. So AC equals, AO equals negative OA. So AO equals minus A. Now I want to find OC. OC is already given, and we're already in the direction of OC as well. So OC equals C. OC equals C. Okay, so AC is AO plus OC. We know what AO is. AO is minus A, and OC is C. So AC equals minus A plus C. Okay, so since we're trying to find, remember we're trying to find XC, so we found what AC is, and X is the midpoint, so this must split AC into half, so XC must equal XC equals half of AC, half of AC. So XC equals half minus half, or we can just say half minus A plus C. Alright, so let me write that again just here, and I'll highlight that. So XC equals, we expand the brackets, multiply out our brackets, half A plus half C. And I'm going to just put a box around that there. Alright, so we found the value for XC, and I'll just write that in here because it looks like there's a bit of space for me to do so. Minus half plus half C. Alright, so it's a bit more of a fuller picture. So now I can try to attempt to work a bit backwards from the problem. I need to find the value of K. So let's see. Okay, so we still can't really work backwards because we still don't really know what we're working backwards from. So how about we now find CD? Okay, because CD is given. We have OC, CD, and we want to find K. So if we want to find K, we're paying attention to this part here, right? So I already have OC, and OC full colon CD is the same as the ratio K full colon 1. So I know what OC is, it's C, OC. So maybe I need to find CD now. So it's starting to make a bit more sense. So I need to find CD. Okay, so in order for me to find CD, I have to, of course, I can't go straight from C to D. I have to go in the form of a triangle. Notice here that this forms a triangle. So I can go from C to X and then from X to D to find CD. Okay. So now I'm starting to attempt to work backwards from my problem. I have this problem here. Okay, OC full colon CD equals K full colon 1. I want to find the value of K. K is linked to this part here. So I have OC, so I need to find CD. So CD, of course, would be going from C to X. We know that XC equals this part here. So CX, so let's just write that down. CD equals CX plus XD. And CX equals minus XC. We're going in the opposite direction. This is XC going this way, and I want to find CX. So CX equals minus half A plus half C. And so CX equals minus times minus half A, which is plus half A, and then minus times plus half C, which is minus half C. And then I'll just put that in a box there. Okay, there we go. So I found CX. And why did I want to find CX? Because I needed to go from C to D. So remember here we have CD equals CX plus XD. So I have CX, I already have XD, so now I can just add them together. CD equals CX, which is half A, minus half C, plus XD, and XD we're given XD already, XD, okay, which is 3C minus half A. Okay, and that simplifies to, we have half A, we have half A minus half A, so that cancels out, and then we're left with half C plus 3C, so that gives us 5 over 2C. So CD equals 5 over 2C. Alright, so I'm going to put that in a box. Alright, so now I found CD, which is this part of the ratio. So let's put this all together now. So OC just like that, right as it's given. OC full colon CD is equivalent or equals K full colon 1. So we're given the vector form here, and then we're given it in ratio form, the ratio form. Now we also have the component vector form. We have OC, OC which is, where is it? OC which is C. OC is C. So we have C full colon, and then CD, which is 5 over 2 C. Okay, so now we can just pay attention to this vector here, these vectors here, or these ratio vectors. Alright, so normally for me to find K, if this was a normal ratio problem, I would say something like, I'll put it like this, I'll say K over 1 equals C over 5 over 2C. And then I would cancel that out, and then we'll cross multiply. But the thing is that because these are vectors, you can't really divide vectors. You can't cancel two vectors out like that. So we're not going to do that way. But what I can say is that C equals K parts. These are parts, remember, we're dealing with vectors here. So C equals K parts. Alright. And so 5 over 2C, since C equals K parts, so 5 over 2C must equal 5 over 2 K parts. Alright, so remember, we need to know ratios in order to really do this question. So 5 over 2C equals 5 over K parts, and notice that 5 over 2C equals 1 part. Yeah? So that means 5 over 2 K parts equals 1 part. 1 part. Which means 5 over 2K equals 1. 5 over 2K equals 1. See, now we have an expression, or rather an equation for K. So now we can just rearrange and find K. So 5K equals 2 and K equals 2 over 5. And that's our answer. Find the value of K. Okay, great. Let's move on to our next vector question. I'm glad you guys have gotten through that. Alright, so let's move to our next vector question. Oh, I believe this is the question you all wanted to see. This is the K scalar quantity question. So, let's just approach this question through our problem solving method, which was this. Alright, so we want to try to build our competence in problem solving, because it's then we can actually gain some confidence in what we're doing. Okay, so let's begin. So first of all, we want to read the question carefully. So we have OAN. Where's OAN? OAN is here. OAN. OMB. OMB. And APB. APB are straight lines. AN equals 2OA. So this part here, AN, is 2OA. Let's draw a line there to show that it's a vector and it's not 20. And M is the midpoint of OB. Here we have our M. And remember, a midpoint always divides a line exactly in half. OA equals A. This part here, OA equals A. And OB equals B. AP, which is this part here, AP equals KAB. So this K is some scalar. Remember, a scalar quantity is not a vector, it's just a normal number like 1, 2, 3, 4, 5. And we have K times AB. AB. Okay? So this question showing us that this length here, this vector here, AP, is K times AB. So it's really a part of AB. Alright? We don't know what this K means. This K could be half. It could be half of the line AB. It doesn't look like half of the line AB. It could be a third of the line AB. We don't know yet. That's what we want to find, where K is a scalar quantity. Given that MPN, now where's MPN? We don't have a line MPN, so let's just draw that in. MPN here. MPN is a straight line, although it doesn't look very straight. Find the value of K. Alright, so obviously this is a very difficult question. So let's refer back to our problem solving notes. So we've read the question carefully. Ask yourself, what type of problem is this? It's a vector problem. Vector problem. Ask yourself, what type of problem is this? What extra information can I obtain from that already given? Alright, well this says, this AN part, it says it's 2OA, and we know that OA equals A. So this 2OA means 2A. Okay, so we're just filling in that. And M is the midpoint of the line OB. So again, that divides B, this vector B, into half. So these points would be half B, half B. So we're just filling in some more information. Alright. Now obviously, like I said, this is a very difficult question, and we don't really have a full picture of what's going on. So it's not like our other problems, like these ones, where we could just work backwards from our problem, right? So what we're going to do is we're going to work forwards. We're just going to keep filling in information, to get a nice full picture of what's going on, and then this might make a little bit more sense to us. Okay. All right. So first of all, we have AP equals KAB. AP equals KAB. So what does AB equal? So let's find what AB equals. We have A to B. In order for me to get from A to B, I need to go through a triangle, and this is our most local triangle here, from A to O to O to B. So AB, see, we're just filling in information here, right? We're just filling in the blanks. AB equals AO plus OB. Now we know what OA equals, so AO is the negative of OA. So AO equals negative A. Okay, so AO equals negative A. So we found AO. So what does AB equal? OB equal, sorry. OB equals B. OB equals B. And so AB equals AO, which is minus A, plus OB, which is B. So again, I'm going to draw a nice box around this in a different color so it stands out. Alright, so AB equals minus A plus B. So AP equals K minus A plus B, and so AP equals minus AK plus, in fact, I'll put the scalar quantity in front of the vector. AP equals minus KA plus KB. Okay? Alright. So we have an expression here for AP. Now we still don't really have enough information. We want to find what K is. We know what AP is. We know what AB is there. So we have an expression for that. So notice that after I've drawn this triangle, I have some more triangles. I have an extra triangle here, and I have an extra triangle here. Alright, so maybe I can find another expression for AP using this triangle now. I have an expression for AP with this triangle. Alright, I have it in terms of AB. So let's try and find an expression for AP. Notice that AP is part of this triangle here. Okay? Well, it's a part of this line AB. This AP is a part of the line AB, and AB is a part of this triangle. Okay? Now we have AP is also a part of this triangle. Alright, so remember, we're just filling in information to try to get a better picture of what's going on. So now I can write AP in terms of this triangle here. So AP equals AN plus NP. Alright, now I know what AN is. I know what AN equals. Okay, AN equals 2A. AN equals 2A. So I want to find what NP equals, right? Now notice that I don't have any values, I don't have any vectors for NP, but I've noticed that I actually have another triangle here. Notice we have another triangle. We have this triangle here. Okay, we have the triangle ONM or OMN. Alright, so we have another triangle here. So if I want to find the length, the vector NP, I know that NP is part of a greater NM here, okay? So in order for me to get from N to M, I must go from here, N to O, and then from O to M. So let me write that. NP equals, actually, we're actually trying to find NM. And once we find NM, then we can find MP. So MP NP equals, so why do I keep doing that? I need to find NM. Alright, NM, got it. NM equals NO, no, plus OM. Okay? Now, NO is the negative of ON. Okay, so ON would be going from here, because OA, this is the vector OA, and then we have the vector AN. We're given the vector AN. So ON, so we could say NO equals the negative of ON, and ON equals A plus 2A, which is 3A. So ON equals 3A, and so NO must be the negative of 3A, minus 3A. Okay, so far so good. We're still filling in information. So let's just remind ourselves of what we wanted to do. Remember, we wanted to find AP. We have AP here in terms of the line AB. Now we've realized that AP is also part of another triangle. It's part of this triangle here. And so we wanted to find AN and MP to try to find AP, right, in terms of this. So we've gone on a little adventure to find what MP is. In order to find MP, we needed to find NM, because MP is part of NM. Okay, so we found NO so far. So we're trying to find NM, remember. We found NO, which is this. So we want to find OM. We know that OB equals B, and OM is half of B. So OM equals half B. So now we can find the whole line NM, okay? We find the whole line NM because NM equals NO plus OM. So NM equals NO, which is minus 3A, plus OM, which is half B. Okay? So we found NM. Now, why did we want to find NM? Remember, we wanted to find NM because the line MP is part of NM, and we wanted to find AP, and AP equals AN plus MP. So now notice that MP is a part of the line NM, which means, now this is probably another place where people get stuck, because we know what NM is, but what's MP? We're forced to actually introduce another scalar. So we can say that MP is, let's introduce the scalar x times NM. Just the same way as AP is K times AB, because it's a part of AB. So that K could be, half, it could be 1/3. The same way here, we've introduced another scalar here for NM, for MP, sorry. So MP it could be half of NM, it could be 1/3, it could be 2/3 of NM, we don't know. So we're saying x times NM. So we can write that again. MP equals x times, what does NM equal? Minus 3A plus half B. Okay? So putting that all together, remember we're trying to find another expression for AP here. We found we know what AN is. AN is 2A. Now we have an expression for MP, so we can just add them together. Look, AP equals AN plus MP. Okay? So AP equals AN, which is 2A, plus NP. And we've realized that MP, let me actually highlight that. MP is this. So plus x minus 3A plus half B. And we can expand that out to get AP equals 2A. Hope we got enough space here. I might have to write this down at the bottom actually. Let's just write this down at the bottom. So we have AP equals AN, which is 2A, yeah, 2A, plus MP. This is our expression for MP. So x minus 3A plus half B. Now we can expand that out the brackets. So we have, so that equals AP equals 2A plus x times 3A, which is that becomes negative, so we have 3xa plus half xb plus half xb. Okay, so now we have another expression for AP. So Now what do? We have two expressions for AP. So if AP equals 2a minus 3xa plus x half xb, and AP also equals this, I'll write it down below. So AP also equals minus ka plus kb. So what do you think we should do? We should make them equal each other. If AP equals that and AP equals that, then they must equal the same thing. So minus ka plus kb equals 2a minus 3xa plus half xb. In fact, this is really an identity. This is really an identity because it's true for any value of x. Now notice what we have here. What we're saying, in fact, what I'm going to do is I'm going to rearrange it. I'm going to rearrange this and get the a terms together and the b terms. Oh, actually, we already have the a terms together. So notice that we have this a vector here, and we have this a vector here. Okay, and then we have a b vector kb, and that equals that, right? So now we can split them and deal with them separately. So minus ka equals 2a. Now we have an equation. We've gone from an identity to an equation. 3xa, and we also have kb equals half xb. Alright, so notice now we have a set of simultaneous equations, simultaneous equations. So what do I need to do here? So what I can do is that I could put x in terms of k. So let's just rearrange that. But before we do that, notice that we're dealing with scalars here. We have a scalar unit here, a scalar unit here, and a scalar unit here. Okay, so we can actually further split that and say that minus k equals 2. In fact, let me just show you what I mean there. What I'm going to do is I'm going to factor out the vector k. Notice that we can say minus k equals 2 minus 3x you see? And for this one, we can say k b equals half x b. Okay, so now that we're only trying to find the scalar k, so we can disregard our vector components there, and so we can just say minus k equals 2 minus 3x, and k equals half x. So now we have simultaneous equations here. These are our simultaneous equations, our scalar simultaneous equations. So now I can just substitute, rearrange this, get it all in terms of k for x. So that would be x equals 2k. Yeah? Now that x equals 2k, I can substitute that into here. So I'm left with minus k equals 2 minus 3, yeah, minus 3 times 2k, which is minus k equals 2 minus 6k. Now I can add 6k to both sides, which gives me 5k equals 2, and k equals 2 over 5. That's our answer. Alright, so as I say again, good luck on your exams. I hope this made sense to you, and just make sure that you go through, if you go through the video, you'll be able to see the list on the problem solving, the problem solving notes, and just make sure that you remember there's two things for maths. There's problem solving and there's information. So you have to get your problem solving up to scratch, and you'll feel a lot more confident with your questions. Alright, well, I'll see you again very soon. Take care.